All right, let's dive into a scenario that is straight out of science fiction, but we're going to ground it in some very real and very, very extreme physics. We're going to explore what would actually happen if someone on the moon, well, decided to take a shot at you. So let's just get right to the big question. Could you survive being hit by a projectile fired from a railgun on the moon? Now, the answer might seem kind of obvious, but the physics behind why it's so impossible is what's truly mind-bending. First things first, what in the world is a railgun? Well, it is not your average cannon. Forget gunpowder or explosives. A railgun uses incredibly powerful electromagnetic forces to fling a solid metal slug at speeds that are almost impossible to wrap your head around. Okay, so before our projectile can even begin its long journey to Earth, it's got to overcome its first massive hurdle, getting away from the moon's gravity. And believe me, that's no small task. Yeah, we all know the moon's gravity is weaker. It's about 1/6 of what we have here on Earth, which is why you see those classic videos of astronauts bouncing around. But here's the thing. Weaker does not mean weak. The moon is still a huge celestial body, and its gravitational pull is a serious force that you have to fight against. So how do you beat that pull? Speed. A whole lot of it. To break free, the projectile has to be launched at a bare minimum speed of 2.4 kilometers per second. That is over 5,300 miles per hour. And this isn't some random number. It's a cosmic speed limit. It's called escape velocity. Think of it like throwing a ball. If you toss it up gently, it arcs and comes right back down. Throw it harder, and yeah, it goes a lot farther, but gravity still wins, and it falls. But what if you could throw that ball at 2.4 kilometers per second? Well, it would never fall back to the moon. Ever. It would escape its gravity completely and just keep going into space. That is exactly what our railgun has to achieve. So our projectile did it. It escaped the moon. It's traveled 250,000 miles through the cold vacuum of space. But now it faces its biggest and most violent challenge yet, slamming into Earth's atmosphere. It's really easy for us to think of air as being, soft and mostly empty. But when you're moving at thousands of miles per hour, hitting the atmosphere is like hitting a brick wall. At these speeds, our air isn't a gentle cushion, it's an abrasive, superheating furnace. And you have to think about the difference in design here. A spacecraft is covered in special ceramic heat shields. Their whole job is to absorb and radiate that intense heat away from the vehicle to protect the people and equipment inside. Our projectile is the exact opposite. It's a super dense tungsten core that's not designed to survive. It's designed to deliver as much raw, destructive energy as possible to its target. As this slug slams into the upper atmosphere, the air in front of it literally cannot get out of the way fast enough. It gets compressed violently, and that compression generates a mind-boggling amount of heat. We are talking temperatures soaring to 3,000 degrees Celsius. That is more than half as hot as the surface of the sun. This quote just nails it. The projectile becomes a man-made meteor wrapped up in a glowing sheath of plasma. This isn't just simple friction. It's a bubble of incinerating, electrified gas that would vaporize pretty much anything it touched, long before the solid part of the projectile even got there. Okay, but let's just imagine for a second that some fragment, some piece of it, somehow makes it through that plasma furnace. What happens at the moment of impact? Now we get to the raw, unfiltered energy of the collision. Kinetic energy is the energy of motion. The more mass and speed you have, the more energy you get. And the kinetic energy of our little lunar projectile isn't just bigger than a bullet or cannonball. It's on a completely different scale. The energy released on impact would be absolutely catastrophic, much more like a large bomb than a simple projectile. So let's bring all these physics concepts together. We've escaped the moon, we've blazed through the atmosphere, and we've looked at the sheer energy of the impact. I think it's time for the final verdict on our original question. So could you survive? The answer is a definitive, multi-layered, absolute no. You wouldn't survive the plasma sheath incinerating you. You wouldn't survive the incredible G-forces from the deceleration. Your body just couldn't handle it. You certainly wouldn't survive the kinetic energy release itself. And even if you were miles away, you would not survive the devastating blast overpressure, that crushing shockwave that radiates out from the impact. Survival is impossible on every single physical level. And that leads to one final, more hopeful thought. This technology, in our scenario, is incredibly destructive. But what if you just flipped it around? A lunar railgun doesn't have to be a weapon. It's a launch system. What if, instead of firing things at Earth, we used it to launch resources mined from the moon into orbit? You could build the next generation of space stations or ships for exploring the solar system. The same exact physics that makes it such a terrifying weapon could make it a revolutionary tool for construction. And that is something really cool to think about.